And we're live. Hey, Or, welcome.
Here. It's a pleasure to be here.
How you doing?
Very well. Drinking some tea.
Nice.
Excited to talk with you about IAM authorization and some other cool stuff.
Me too. Me too. Definitely. Definitely. What tea are you drinking?
I'm drinking English breakfast tea with a bit of milk. I like it really strong. That's kind of my thing.
Nice.
Um, yeah, and also with the late hours, it actually has more caffeine than coffee,
Really?
so it helps. It helps.
Nice. I'll give it a try.
You should.
Cool. So, what's your story? Tell me, how did you get started? What was your journey? And yeah.
Sure. So I'm rather a cliche of an Israeli entrepreneur. My background starts in the intelligence corps in the IDF in a unit called 8200. I was a developer, officer, reverse engineer, yada yada yada, project manager, etc. Afterwards, I worked as a first employee in a startup that did containers before containers were a thing, but with a really bad go-to-market. Afterwards, I worked at a couple of other startups. Was a VP of R&D in a cybersecurity company, um, doing solutions for governments and like-minded agents. I only worked on defensive solutions, and I'm really proud of that. And after that, between late 2016 and up till 2 years ago, I co-founded and ran as CEO of a company called Rookout, which is a developer tool solution in the production debugging space. I might even go as far as saying the company that created that space. And most recently, I started work on a new company called Permit.io. We focus on authorization and access control. We enable developers to quickly bake that into their products instead of building on their own. In my previous company, Rookout, I ended up rebuilding access control 5 times. And I thought that's probably 5 times, 4 times, if not 5 times too much. I got together with a good friend of mine, Asaf Cohen, who used to be a student of mine in the intelligence course 16 years ago. I feel old every time I say
Talk about closure.
that. Yeah. And Asaf worked at Microsoft, Facebook, Clarity. In Facebook specifically, he also worked on developer tools. And he got to see how advanced their access control can be. So they
Mhm.
invested half a decade of a team of 30 people to build that level of permissions and access control that they have. And that also kind of got us to understand how deep the rabbit hole goes. Not just the pain of rebuilding it, the simple stuff ourselves, but how big it can get. And so that's what I focus on today.
Nice, nice. That's really cool. After listening to a podcast that you did, I realized how
Mhm.
deep the rabbit hole goes. Actually, and I never really understood before how complex this subject really is. And there are a lot of confusing terms, right? There's a authorization, and then you have authentication, and you have everything under this umbrella term of
Umbrella.
identity access management. So maybe you could help me make sense out of these and out of these terms.
Yeah, for sure. A lot of people confuse, especially authentication and authorization. They are also often abbreviated similarly. So authentication is abbreviated as auth-n, and authorization is abbreviated as auth-z. So people are just seeing auth, and they don't know where the line separates between them and how it goes. So taking a step back, both those items are part of a bigger umbrella term called IAM, Identity Access Management. Identity Access Management deals with all the elements of how we connect people and other solutions to one another. It starts with identity management, solutions like Okta and Azure Active Directory, which are responsible for just managing the directory of identities that we have for an organization. So let's say I'm running a company and I want to allow people to interact with the systems. I need to know who are these people and just track the different identities and say these are people that belong to my organization and not. Authentication um, comes when you're starting to use products in your organization. So each of those products needs to verify that the products or services needs to verify that the people that are coming into the product are who they say they are, that, to authenticate that they are the identity that they claim they have. So authentication solutions connect to identity management solutions to get the basic list of users and check the incoming user against it.
Mm-hmm.
And then it moves to authorization. So now we have a user, we know who they are, but now we need to decide what they're allowed to do inside the product. Are they allowed to create new entries in it? Are they allowed to delete data? Are they allowed to invite other users in? So that would be access control and specifically authorization. And all of these solutions kind of work in tandem. You start by logging in into application, that then you go through authentication that checks you against the identity management solution of the organization, creates what's often called a JSON web token. That's the modern standard. JSON web tokens are cryptographically signed documents that the authentication solution provides to the authorization layer. So it says, you're Yair, you work at CoreLogics, for example, and you belong to the R&D department, and you are, I don't know, you're so and so years old. The authorization solution can that receive that document, and then it knows a couple of things about you. First of all, it knows who you are, and it has additional attributes it can use to either translate them into elements in the authorization systems like roles, which I guess we'll talk more about in a second, or just immediately assign access to you based on that. For example, let's say if you're and part of the R&D department, that means that you can work with the Git repositories or with the source code of the company. So that's something that the authorization solution can immediately do based on information coming from the authentication layer. So that's the line between authentication and authorization is authentication identifies who you are and gives hints on what you can potentially be assigned to do. The authorization solution deals with the actual product, the logic within it, and actually enforcing and assigning access. And that's kind of the entire IAM space, and specifically getting at
Mm-hmm.
authorization.
Nice, I see. And authorization is not just for. Is it just for users access, or is it also a term that's used for managing access between different services, for example?
Yeah, so any entity, it could be actual user, a human being, and it can be a different application or a different service. Um, both these types of entities can be assigned access. They both have identities, either as a service or as a human being, and both can have different rules or even roles to give them access into other services within the system. Oftentimes, services are acting on behalf of users. So that service, especially if you're working with microservices, so one microservice would ask another microservice to do something for them. So when they do that, there's kind of a trickle down of access rights. So there's the access right of what that service is allowed to do in general in the infrastructure level, which other services, for example, it's allowed to talk to. Is it allowed to connect to the database, etc., etc. And there are the access controls that are given to it as part of acting on behalf of another user. So that service is currently handling a request for a specific user, and then it should get specific rights to do things according to the access granted to that specific user.
Mm-hmm. I see. I see. Okay, that's pretty cool. I see. There are so many solutions though to authorization and authentication. So many different things that one can
Mhm.
do. And before we dive into those things, actually, I'm curious to know about the history of authorization and how did it start? Like
Mhm.
how did authorization start in the web in general?
So before it started in the web, it just started
Right.
in the world, right? So you had a concept of having a house, for example, or a building, and you'd have a door, and you have
Mm-hmm.
locks on that door, and you'd have maybe people, you have like guards or concierge in the entrance deciding who can go in. So a lot of the basic concepts of access control were implemented in just the physical world before they were translated into the virtual world, into
Like many
computing world.
things, right?
And you'll see that, yeah, like a lot of things. Um, but it's important to understand that um, there's a lot of kind of basic concepts and logics that evolved as kind of like academia in authorization in the basic world that got translated into kind of the core concepts in the virtual world. And you have things like different models, like role-based access control and attribute-based access control. So people were thinking for a long time, how should they divide and assign access? Um, and one of those concepts was kind of dividing how you approach both identifying people, and that kind of touches more on authentication. But then also, once they're authenticated and they're in the building, how can you assign different access to different departments, different doors, different sections? And then you started at different keys and different, and you had um, like fabs or like other kind of items that you can use to be granted access to specific areas. Um, so that's something that evolved for a long time, and also the different roles of people standing guard and keeping both enforcing access and also keeping track of access, audit logs, especially if you think about banks, like who can access the vault and who access the vault when. That's like a really ancient concept. Just having that kind of log. um, and so it started there. We started building computers, we started building networks, and then connectivity kind of started to spike, and it's still increasing as we speak. Like more and more things are becoming more interconnected, and so this problem kind of grew. But we kind of stuck to the basic models, and then maybe this would be kind of a good point to kind of map them. So there, I think, three main models that we used to think about authorization that are still used today. Before I mention them or dive into them, it's important to understand that these models are not implementations. They are ways of thinking about how we'll go about implementing access control. And there isn't one model that solves all the problems. And the biggest problem with authorization, I think, nowadays is that it's hard to understand all the minute aspects of these models and also how you shift between them, because you start with one solution and then you end up having a different solution evolve. And then you need to switch models, and that can be very hard. So let's start looking at those models. So the most basic one and the one that people heard of the most is RBAC, um, role-based access control. So the idea is very simple. We'll assign roles to different entities, humans, users, or services, and they directly gain access according to their role. So, for example, if you're an admin, let's say you can do everything in the system. But if you're a viewer, you can only read files, but you can't change them or invite other users. And if you're a viewer, and if you're an editor, you can both view and edit, but you can't invite other users. That's kind of the most common schema of RBAC. But of course, proprietary applications will have proprietary roles. So let's say we're doing a billing application. So you'll have a CFO role who can see all the billing logs and can see all the invoices and can manage them. And you'll have a financial auditor that can only see the final bottom line and fiscal reports, but he can't see the invoices themselves, etc., etc. And you can think about a system for lawyers and a CMS, and basically any type of application can have unique roles. So that sounds like a very good model, right? You can map a lot of the basic concepts for most applications. So a lot of times people think that that model will cover them forever, but that's kind of a naive thing, because then the requirements start coming in. So people would say something, oh, let's say a customer says, I want to enable people in my organization to edit files here, but I want to make sure that they only do it during the work week, because because we don't, if they use the system in the weekend, I have to pay them more money, and that's a problem for me. Or I want to make sure that they're doing this only on days they're not on vacation, because if they're using the system on vacation, it's probably an attack or someone abusing the account. Or I want to do something more advanced. Like I only want to allow a user to do something only if he paid for a specific feature. So he can use the basic features, but there are more features, and you can use them only if he paid for them. And so what do you start to do then? So you have a role for users that, so you have an editor, weekend editor role, or do you have like a
Mm.
paying editor? It's quick, and the more kind of elements like that they start to pile up, the entire model just crumbles. And that's before, so that's just touching on a few examples for user requirements, for customer requirements. We haven't touched on requirements that can come from the compliance or security, and those often just pile up one on top of the other.
Can you give a few examples
So
of that,
RBAC
maybe,
is,
of example from compliance and security?
mhm. Yeah, so compliance would want, for example, to comply with things like SOC 2. So SOC 2 requires, SOC 2 or ISO, mostly require you to have processes in place that enforce good practices around accessing sensitive information, or could be information that's related to privacy or is part of critical infrastructure. And then you need things like approval flows. You can say a user can edit our production configuration file, but only if he was approved to do so by another team member, or by the team lead, or the
Hmm.
CEO approved it. So now we need that. There's now an additional attribute like, was this request approved? Another example would be, you want to silo things. You want users to only be able to do things within their own tenant. So there's the entire world of multi-tenancy. Maybe I'll come back to that later because that's a whole topic by itself. Um, and there's the concept of ownership. So you can edit the things if you're an editor, but only if you're the owner of a specific file. So there's being an overall editor and an editor with ownership of a specific item. And so those are like
Yeah.
examples of
It,
how
it
this
sounds
can
like you can
become
just keep
more
going and
complicated.
going and going and find a lot more. So it seems like RBAC is like a more simplistic model. And so would you
Hmm.
say that for like new startups or someone who's just looking to set something up fast, RBAC is like the maybe the fastest model they can start with?
No, the fastest model they can start
Nothing.
with is nothing. And I actually recommend to start with that model often, because maybe you don't need access control, and maybe your product is not actually good enough that it worth adding access control to. So I wouldn't waste time on it. But I would invest time in thinking on how you'll add that in the future. And the stepping stones are usually something like this: you start with nothing, and then you start with kind of a binary approach. You're either an admin, kind of a super admin, or not. And then it's usually the customers are the users, and
Right.
we're the admins. And then you say, oh, so now the customers, they want some more fine grained control. So they want different roles. And then you add RBAC. And then you add something like ABAC that we didn't dive into yet, but we'll do in a second. So the key here is to understand that there are different models, and you'll need to shift between them, and you need to build your technological stack so it will be easy to
Hmm.
shift with them. Because if you're going to grow your business, if your what you're building is going to be successful, you will be shifting. And the best practice that's kind of growing today with the kind of concepts of microservices is to decouple out the logic for authorization and have it as a separate microservice. Once you do that, even so, it can initially be a separate microservice or a separate function, even that just doesn't do anything. It just always returns true, right? You are always allowed. That's the given. But once we want to go and add more logic to it, we can do that without changing the
Yeah.
entire application. So it's kind of more about setting the groundwork of enabling your product to add access control according to the demands that it has at any moment in time. And I think you can already tell from the few examples that I've given, and also from my personal background, is that this is an ongoing story. It never ends. There will always be another customer requirement. There will always be another regulation that you need to meet. There will always be another audit that you need to pass. Think about, so a lot of companies end up when, for example, when they IPO, or when they start working with governments, or when they start working with more secure organizations, or when they do GDPR, or when they do CCPA, or any GDPR is like privacy regulations for the European Union, and CCPA is the same thing for California. So all of these kind of add more requirements, and they'll likely show up in some way or another. And when they show up, you need to be able to adjust to them in an easy way without having to refactor your entire application. The problem is that most people don't do that. They just go gung ho. They just write the authorization code baked directly into their product. And then when they need to change, they find themselves spending something like 8 months or three people to refactor the entire thing. And while not all of that time can be saved because you are building new features, a lot of it can be saved by removing the need to change a lot in the
Mhm.
existing system.
But if you move from like a simple authorization model, even something that just has like an admin and a user, to something like RBAC, can you fully avoid touching all your different services, or you can just try to make the best out of it, try to isolate that logic as much as possible, but will you still need to touch all the services and work hard to change it at the end of the day?
So depends on if you're doing a good job or not. You can definitely get to a situation where you don't need to change them at all, but it requires understanding and some sophisticated architecture work, or using a solution, using existing open source solutions, or using services that already exist out there that to build with them, and then they come baked in with those kind of best practices. Frankly, that's what we do with Permit.io, right? But you can also do it with open source, including our open source Opal. But if you do it on your own completely, you really need to understand both how these models work, how you shift between them, and how to connect
Hmm.
this to your code. And in the end of the day, with the right concoction of uh, well architectured SDKs and microservices, you can definitely get to a situation where you can upgrade your access control even without writing any more code. It can just be something that layers on top, and you just change
Hmm.
configuration.
When you said to use a open source, so let's imagine I'm starting at phase one. So even phase two, or after the part that I have no authorization. I want to have a simple authorization, a binary one. Either the user is authorized or is not. What kind of tools can we use, or open source tools can we use at this phase?
Yeah. So first of all, I'd start with saying that you don't have to. You can still keep that just as a separate service, and have um, a clear way to query that service. And at that point, you should still be okay. And you'll be, when you take the next step, when you're moving, for
Hmm.
example, into RBAC, that would be a good place to kind of upgrade it with the additional capabilities. If you have the added attention span, you can already do it at that point in time. And there are multiple solutions that you can look at. I won't mention all of them, but I'll mention a couple. The leading one, I think the one that has the best maturity and community adaption, is a project called OPA, Open Policy Agent. It's a CNCF, a Cloud Native Computing Foundation project. It's a graduated project. It means that it's on the same maturity level as Kubernetes. Um, and what OPA does is essentially we probably should have touched um, on XAML in our journey. So there's aside from models, there have been all kinds of implementations for authorization, and XACML is one example for it, and it defines all kinds of ways to architecture um, access control. So, for example, it defines the concept of policy decision point and policy enforcement point, PDP and PEP. So OPA is a type of PDP, policy decision point. So you'd have an SDK in your code, for example, there would be a policy enforcement point, essentially something that you call and you wrap with an if condition. If the policy enforcement point, the SDK call, returns true, then you can perform
Mm.
the code. Otherwise, return a Thor 3 exception. And that enforcement point would query the decision point, which, for an example, a way to implement it would be with OPA, with, as I said, Open Policy Agent. Going back to OPA, so OPA, if you're familiar with Prolog or Datalog, it's kind of like, it's essentially an expert system. It's a solution that runs code, and it's Turing complete, so you can write basically any application on it. But it specializes in writing rules for policy decisions for enforcement. So in OPA, you'll be defining the rules of your policy. For example, only users that are part of the user list are allowed. So you'll have a rule called allowed, and it will define if user is in the user list, allow them access. That's a very basic example of a policy. And you can have multiple allow rules. For example, allow if he's a user, or allow if his name is Yair. You can have that rule, for example. And OPA would run through all the rules and try and find if there's a rule that says that you're allowed to access, and if not, it will return that you're not allowed. OPA comes with a couple of advantages. So for one example is the language that I've just described for OPA, which is called ReGo. And ReGo is highly optimized. OPA itself is written in Go, and it's really written. It's really designed to be very performant and so it will return answers to queries quickly. In general, you have this tension when you're building authorization queries. You want them to be as complex as you might need, but you want them to be as tailored for the situation you're doing now, and you want them to always be efficient. Uh, a way to think about this is that, for example, if you're writing a microservice, on average, every microservice uh, has 3 authorization queries as part of a request handling. So if each one of those requests is slow to respond, your entire microservice would be slow to respond, and you're going to have a bad time. So using a solution that helps you write performant rules that return quickly is a good way to ensure that um, your performance of the service you're writing will not be hindered by your authorization layer. And because it allows you to write any rules you'd want, you can always upgrade it with more rules and then switch between policies. And here comes the kind of the one of the biggest trends we're seeing today, which is policy as code. Instead of writing policies as configuration, which it can be limited and hard to maintain, and there are no best practices on how to just work with it, we're adopting all the classic patterns of writing and working with code. So we can manage our code and load it into a Git repository, and we can do code review on it, and we can assign access to the repositories, and there's a standard way to deploy it, and there's a good way to update it and also keep versions of it. So we can adopt all the power of code and both how we manage code and translate it into the uh, policy authorization space. So that's
And
OPA.
you say that OPA
OPA,
or any kind of alternative is mostly used when you need to do something like RBAC that's more complex, and now you need to perform some sort of strategy, and you need to enforce some rules and policies, and it starts getting, if you're gonna try to do this on your own, then you're probably going to make a lot of mistakes. Yes, and it's
a
also
lot
not
of
going to be
mistakes.
as neat and clean and easy to understand.
Yeah, exactly. And you'll be missing a lot of best practices that are kind of baked into the tool. And you'll be missing additional integrations and utilities that you can use. So, for example, a classic part of authorization is to start by verifying what you got from the authentication layer, processing JSON Web Tokens, which we mentioned before. So you can start finding packages and compiling this on your own, but it's really easy to make mistakes with cryptography. And those are really painful mistakes that you live to regret. Because if you do those mistakes, an attacker will find them and it will end up abusing and subverting your system. So it's better to use something that already has those things kind of baked in and verified. And that's one of the things that OPA does. And I can give you more examples, but I think that's a very clear one. Um, so you can start with OPA from day one. You can do it even if you just also if you have no policy. You can just have an OPA agent always returning allow, just like with the function that always returns
Mhm.
true we ended before. But it will be it's what's important to connect to what we said before. It's important to have this kind of space, a block where you can plug in more authorization logic when you need it. The sweet spot would be either when you start with basic roles or when you move into something more advanced. So that's usually where you'll really need something like this. You can get away with it when you just have no logic or very binary logic, but beyond that point, it will
Mhm.
start to be painful.
By the way, Or,
Um,
you said that
so
OPA
OPA is
is
one.
in
Yeah,
Go. Do you know if you can use do you know if you can use
it's written in
OPA
Go.
in Node.js, or are there like any alternatives? I know a lot of our viewers are web developers and use Node.
Yeah. So OPA is written in Go, but you're not. While you have the option of embedding it
Hmm.
in your service, like you can run it also as
Mm.
WebAssembly. It can compile the Go can compile to WebAssembly and can run it in your service. That's not really the way it's meant to be used. It's meant to be used as a separate microservice. So you don't interact with it with the code of it directly. You query it through a RESTful API. And what you ideally do is you create an SDK that wraps those calls into OPA. And if you're using Permit IO, for example, we already provide those SDKs for you, so you don't need to write them on your own. And we have support for Node.js. But if you're using OPA directly, you can always write that SDK yourself. It's not that
Hmm.
complicated.
I see.
But it's important that it will be a separate microservice. If you just do it as a library, it's still what often happens is that still the code of the authorization layer and the application itself gets tangled. And it's important to remember that you'll probably have multiple microservices or at least multiple services that would require um, the use of that logic. And if you need to embed the same library in each of them, what will start to happen is that it will also start drifting in versions,
Mm.
and that's also a pain. So it's a lot easier and a lot safer to decouple your policy and code and use a separate microservice
But
with
let's say
OPA.
even if I have OPA like as
Other,
a separate microservice, will I still need to like create another microservice that will then communicate to OPA, or is it enough just to have the OPA microservice? It can fill all the needs, and all my different microservices can just contact that.
yeah, so that's the idea. All your different microservices can connect to that. They might end up connecting to different OPA instances that have different policies loaded into them. So you can have each microservice loaded, having its OPA sidecar loaded with different policies and data for its
Mm.
performance. And it actually makes a lot of sense because your billing service and your I don't know, your email sending service, they require different information. And so they usually also have different policies on who can do what within them. And that's where we're starting to get into another pain point of working with OPA. And that's where kind of Opal, the open source we created, kind of shines at. But before that, I want to give a few more examples of policy agents. Another good example, which is gaining some popularity, is a project called Oso. It's very similar to OPA. Instead of it's a data log like engine. It has policies written in a language called Polar, which is somewhat similar to Rego. I actually think it's a more elegant language than Rego. Um, the Challenge with also is that it's still not as
Mhm.
mature as Opal, and also that it doesn't come as a separate service. It comes as libraries, and then people make the mistake. I at least call it a mistake. They make the mistake of baking that library, compiling that library, or packaging that library into their service instead of creating a separate microservice. So if you decide that you like also better, use it, but I highly recommend that you still create a separate microservice and not just bake it into your code. And another example, which is actually more an older project, but not necessarily as elegant or mature, is a project called Casbin. Casbin has been around for a while, and it was mostly used for
Mhm.
IoT projects. But I find that its documentation and quality is not as good as OPA. But it's a good option if you're looking for other options, or maybe you're working more in the IoT space. It's a valid tool to look at. Um, so going back, so now we have these policy agents acting as policy decision points. We have our software querying them for enforcement. Now we need to load them both with policy and data so they can make the right decisions for us.
Mhm.
Right. So obviously you need to load the policies in because otherwise they have no code to run, and they also need the relevant data. For example, in the policy we mentioned before, only users that are in the list in the access control list are allowed to use the system. We need to give them the list of users, otherwise it can work. And now really depends on which level um, of the application or of the product we're working on. So access control, as we mentioned before, is applicable to multiple levels. It starts in the physical realm, right? Again, locks on doors. It moves next to network level access control, like firewall, zero trust networks. Then it moves to infrastructure level access control, which service can talk to which service. And lastly, application level access control, which users can interact with each users on
Mhm.
which features. The higher you climb, the more data you need, and more complex are your rules, and more proprietary they are to a specific scenario. So if you're using, for example, OPA, it's like the place that it shines is the infrastructure level in Kubernetes, especially through a project called Gatekeeper. So which service can talk to which service in Kubernetes? It's called
Mm.
admission control, essentially. Um,
By the
and
way, or let's talk about that for a bit. Maybe when would you want to do admission control? Because a lot of the times, services can just be in the same network, and they're protected this way. So all the services can that are in the same network can communicate, and no one outside the network can communicate with them. So is that not enough?
it really depends on what you're building, but often, yeah, it's not enough because just let's just think of a couple of scenarios to kind of paint the picture. Let's say I have separate machines, separate containers, or
Mhm.
separate clusters servicing different customers. They're handling sensitive data for each customer. So if I allow, by mistake even, different tenants, different customers to interact with one another, that can be a serious data leak, if not a full blown
Mhm.
security incident. So it's really good to silo those. In general, one of the key principles of security is containment. You want to silo things separately that are not supposed to touch one another, because otherwise, bad things can happen, essentially. Another example is sensitive information. We're just hosting our own sensitive information. For example, credit cards, or PIIs, personal identifying information, or PHIs if you're working on medical information, for example. We just have some services that we've written that are used for marketing. They're just sending people emails about our new features. If those by accident end up um, affecting retrieving data, or in some way affecting in some other way affecting those critical services with the sensitive information, we're
Mhm.
gonna have a bad time. So we want to in advance separate those. um, Obviously, when we climb up in the application stack, it becomes more complicated because we have, for example, the front end service needs to talk both to the billing service to show you your billing information, and to your um, secret store if you want to edit your own secret information. So it's not as easy to silo that just, oh, you're allowed to talk to the service or not. You need to more fine grained access in the level of the concepts of the application, and you need to connect it to the user and not just the service. And so that obviously becomes more complex. And then what we need to do is we need to make sure that each service has the right each OPA instance working for a service has the right information to
Mhm.
make decisions, and have that in a consistent way in a applicable amount of time. So in the services picture in the infrastructure level, we could just deploy the configuration of which service can talk to which service as part of the deployment of the application. And we can update that as part of deploying a new version. But when we move to the application layer, things now change more quickly. So, for example, an example that I often like to use is a policy like only users that have paid for a feature can use it. That piece of information, who paid for something, is dynamic. Someone can swipe a credit card now, and now they're a paying user. And we don't want to wait for the next time we deploy a version so they can get access. That's a way to get annoyed users that just drop out and
Yes.
don't use you anymore. So you need a way to keep your policy agents up to date with relevant information in real time. And it's actually more complicated than that. We need to aggregate information from across the space. That billing information nowadays doesn't sit in your database. It sits in a third party service like
Right.
Stripe or PayPal. So we need to be able to track those in real time and on the fly retrieve. So when someone pays in Stripe, we want to get that event and propagate it into our multiple OPA instances that we're running for
Mm.
multiple services. So that's where a open source project like Opal comes in. Opal enables you to create event-driven architecture that brings in updates into your OPA instances in real time. Opal, by the way, stands for Open Policy
So are there like
Administration Layer.
stateful instances? So
And you
instead of having to
basically,
query Stripe every time, they're stateful and then it's a lot faster.
yeah, it's so they're not stateful. You have state still resides only in the OPA instance. So that's the only place that holds the data. But Opal tracks events. So if there, for example, there incomes an event from Stripe saying a user is paid, that now tells the system that it needs to go to Stripe, fetch that data, and bring it into OPA so it will become available. And it happens in the background in an asynchronous fashion. So what Opal does is tracking events and using those to keep OPA updated in real time without you having to specifically go for every action and write a new logic that will bring that
Mm.
data in. And then to where you can kind of scale it. And also because it provides a topic-based mechanism, you can now have different. So the Opal architecture is an Opal server, which receives the events, and Opal clients, which get the instructions per event and update the Opal instances that reside next to them. And you can have each Opal client subscribing to different topics. So the Opal client managing the Opal instance for your billing service will subscribe to billing information. The Opal client next to your user access list would subscribe to that information for its service and OPA instance that it's
Mm.
managing. And then you also get silos. Each service only has access to the data that it needs when it needs it,
Nice.
but it can go through the same kind of
That's amazing. That's
architecture.
almost like every one of those open instances is like its own application, right? It has its own like messaging and all of that. So it's pretty cool.
Thank you. We worked really hard on it, and we're very proud of it. It's the project is very young. It's only like half a year old, but it's already in production in companies like Tesla,
Nice.
Zapier, Accenture, and a dozen other companies. And that's also, you can see the power of open source. Like, you put out something good out there and just people adopt it,
Cool.
which is awesome, and
I'm
contribute
definitely gonna
back, which
check
is
it
a
out after
always.
the podcast. I'm very curious. So sounds really good.
Please do. You're also welcome to join our Slack community. So, like, if you or the viewers have questions, you'll find me there. And as you can see, I'm really excited to talk about these topics. So I'll be happy to answer questions there as well.
Awesome. Awesome. So I believe maybe the last thing before we're talking about is after RBAC, or was there something that you wanted to say before?
Oh, yeah, yeah, yeah. So we have some more models. So we probably won't cover all the models now, but like we should touch at least two more. So one is ABAC, attribute based access control. So the idea there is that we break down all the elements that we have into different attributes, and then we can basically define conditions for each of them. So, and you can have attributes both on the service, the user itself, the current situation, and other peripheral data. So I'll give you an example of a policy that is based on attributes that won't work as roles, but also builds on roles. So ABAC extends
Mhm.
RBAC to some degree. So we want something like this: only users that are editors, that have the role editor, belonging to the marketing department, currently connecting from the US, and only during work hours, and have paid, are allowed to use this
Mm.
feature. So if the user paid or not, that's a Boolean attribute of the user or its billing plan. The geolocation of the user is another attribute of the user, or its connectivity. And there you probably want to do something like, let's get the IP address and translate that into the current geolocation that we have for that. Um, the role of the user is something that is managed by the authorization system itself, but it's an usually an attribute by itself, but it's assigned. The assignment is connected to the user, and the current time is just like a global attribute that we have. And these are obviously examples, and you can using this example, you can probably imagine a lot of specific attributes that will be for our specific services. For example, I don't know, if you're a system for lawyers, only if you are a partner in the firm. So being a partner is not the same as a role. You might have you might be an editor of a specific file, but being a partner is like an additional attribute.
Yeah, like the
Um,
ABAC, I feel like really gives you unlimited options because now you can compose different attributes instead of just a black and white approach. If you have this specific role, this user can do X, Y, and Z. Now you can compose all these different attributes and pretty much do um, anything you want, really, without having to create duplicate roles
yeah,
for everything and trying to manage that.
Yeah, so ABAC is super powerful. It's very generic. You can define a lot of things in it. It's almost complete. It's not necessarily Turing complete. There's like an extension of it, or a different flavor of it, called policy based access control, which is a version of ABAC that is more
Without
Turing complete, let's say.
synonym.
But yeah, you can say that. But something that I want to kind of float into awareness here is it's not a bed of roses. Like, if you think, oh, I'll just go to A back from the beginning. A, it's hard to manage, and B, it can be very challenging to build it in a
Hmm.
performant way. So, for example, one of our employees in Permit used to work for a company called Clarity, and they decided to upgrade to ABAC. And because they didn't plan the data collection correctly, the process of just retrieving from the data sources, from the databases, all the data that is relevant for the ABAC decision basically killed the entire performance
Yeah.
of the system. So unless you know what you're doing, I wouldn't jump
Yeah,
directly
it's
into
it's
AI.
really dangerous because if you kill the performance on the authorization level, there's literally nothing you can do everywhere else that will improve it. Even if you have the fastest, I don't know, indexing and all of the different optimizations you're going to try to do, and it's not going to help.
Yeah, that's what. Oh, again, it's another example where if you use best practices and use existing tools, you can save yourself a lot of pain that you might not even be aware of. So I'm like, I already know this pain because I've experienced it and saw it otherwise. But most developers, like, it's not something that would come into your mind. It's like, yeah, we're just evaluating a couple of conditions, doing a few queries on the database.
ABAC.
What's the big deal? And then you actually build it, and then it turns out to
Hmm.
be a big deal. So that's why, for example, with Opal, we made the data loading module asynchronous. So it's not part of a authorization query. It happens in the background. That already kind of reduces the pain. But you need to build your policy correctly. Like if you do it with Opal, you still need to write the right code. Opal would help you to write performant code. It will give you good templates and will give you good ways to optimize that code. But you still need to avoid stupid mistakes. And so again, I wouldn't jump to the most complex thing, but always have a good baseline that I can
Hmm.
extend on
What are
gradually.
like the practical
So
steps of
that's
going from RBAC to adding more, going to like an ABAC model, adding attributes? How does it look like?
mhm. so. So first of all, also need to cover ReBAC, relationship-based access control, which is another alternative to extending RBAC. So first of all, you need to figure out what's kind of the right model for you. Well, I'll say this: if you're building this on your own, you have to figure these things out. If you're using services, you don't have to.
What do you
We do
mean?
that for you. Uh, so with, for example, with Permit IO, we give you
Hmm.
UI interfaces and APIs that you can generate a policy with without having to understand what kind of a model you're building. But when you add things, for example, you'll start with role-based access control, which just give you a UI that you can quickly create roles and assign permissions to them. And then you can say, oh, I just want one attribute. We kind of create code in the background for you. We automatically generate Rego code for you in a way that is performant and works well. And you don't even need to think about, oh, am I doing RBAC now? Am I doing ABAC now? You just define in the UI or the API how you
Mm.
want it to be. And we do the heavy lifting for you. So that's an exception.
Are
But
there
if
any
you do it on
trade-offs
your
to
own,
that,
then
by
it's
the
okay,
way? So
obviously,
it's
to
a,
do
it's huge
it.
advantage, probably saves a ton of time and work. But what's the trade-off?
Uh, I don't know that you're using a service. That's the trade off.
But not in
It's
when it
like
comes to
it used to be
performance
like
and different metrics like that. There's no significant trade-off.
so we know that this needs to be it's a critical infrastructure, so we build it
Mm.
to be highly performant, and we use all those best practices we've been talking about, so we bake them into the service. um, but some people, like, they don't like using a third party service. It used to be the same thing for authentication. Like 5 years ago, if you'd go, or 10 years ago, if you go people and tell them to use something like
Hmm.
Auth Zero or one again, they would go, "Oh, I don't know, I don't trust something that critical to a
Mm.
third-party service." But nowadays, it has
Yeah, it's
become more kind of
ubiquitous.
accepted,
You see it
and
everywhere,
yeah, and it's becoming, not that it's actually more than accepted; it's become the norm. Like building authentication on your own
like a
would
bad
would be
practice.
kind
Yeah.
of insane today. So authorization is not quite there yet because the solutions are just coming up, but it will probably be like that in
Do
like
you
three
guys have
years
any
from
like
now, or
unique
5 years.
selling position? Anything that makes you guys difference at Permit?
Yeah, so we focus on experiences and not on infrastructure. There are a lot of other companies out there that will give you an API to that you can build with, but we kind of recognize the fact that as developers, you don't want that. You don't want to build authorization. It's not an interesting part of your product. You have your own core technology and features to build. Authorization is not part of it. So you don't want just an API in which you can build on top user management and API key management and secrets management and audit logs. We just give you all of those out of the box. We give you a policy editor that you can also give to your customers if you want them to delegate capabilities to. So we try to cover everything end to end, and that's the main differentiation. But there are other services out there that give you good APIs that you can build with, and of course, there's good open source. I think, especially if you're sensitive about using a third-party service, or if you have to be on-prem, um, using those open source solutions is a definite
Hmm.
good option, an alternative.
I see.
And we're also gradually putting more open source solutions out there. We're just launching another open source project actually, called Optoggles. So um, you need access control across your system, not just in the back end. You need it on the
Right.
front end, right? So because if you want to give an error, a strict error in the back end, like give that 403, but when someone comes in the front end, you don't want to show them that button that will give them that
Right.
exception in the first place. So there's now the question of how you synchronize your front end with your back end. Well, how would you go about doing this? By the way,
So is
just
it
kind
is
of
it yeah, so is it in terms of
getting.
like actually accessing a certain route so the user can access it, or accessing different elements within that, feature?
So it's elements. You're
Yeah.
building a front end. So let's say you have a billing service, and they're not allowed to use billing. So you don't want to show them the navigation option to
Right,
go into
right.
billing.
Yeah. So I guess something like yeah, maybe some sort of service that holds that state, um and yeah, it would have to check every time with the user whether they have the access. Yeah, I've done it multiple
Yeah,
times. It's like
it's
if you architect it right, it's nice. But if there's a better solution out there, then I'm definitely curious.
so I'll can give you the evolution of that. So often people start with just sending queries to the backend per item and getting a result if they're allowed to do it or not. And you can even potentially query OPA
Mhm.
directly from the front end. But that's pretty bad idea because you need your front end to fully understand how to work with OPA or the backend service, and you're doing a lot of back and forth to get the different flags essentially that for what you're displaying in your front end, and also you're not really caching this. Like you need a CDN for that information if you want it to work well for all your front end clients, right? You don't want a lot of
Mm.
that back and forth traffic.
So I guess what
It's
you're
not
saying
efficient.
is also not so. What my experience was working with more simple models like RBAC. So usually, I got a certain role, and then th- that information was available usually on the start of the page, and I could simply check that. But what you're saying is that you can get to situations where specific things need to actually make certain different requests in order to see whether they have permission or
Yeah.
not, and that can get way more complex. Hmm.
Yeah, yeah. Also, you don't want to re-implement the policy in the front end. I forgot about that option. That's the worst one because if you say, okay, I write a policy. If you are an editor, then you can use these buttons. But what happens if we decide to change the
You have to
policy
do
in
it
the backend?
twice.
Now we have two.
Hmm.
Yeah, it's a
True.
horrible idea. So we want to get the decision from the policy from the backend from one source of
Hmm.
truth. um, Next step of the evolution is doing something like GraphQL or kind of bunching up all of the authorization queries into one request. That's better, but we still need to take care of the CDN stuff. We still need to create an interface that will take the policy information and expose it in a way that is consumable by the front end. It's a lot of work. Um, with so the next step, the one that we're offering with Optoggles, is to leverage something that you already are using in your front end, and that's feature flags. It's exactly that. So feature flags like launch darkly, split IO, etc., are flags that you use to toggle what to
Hmm.
display in your front end. So what Optoggle does, it listens into Opal on changes in your authorization layer, and then queries OPA for specific policies, specific rules, and creates feature flags from them and just loads them into your feature flag solution. And the feature flag solution already takes care of the CDN and availability and also the different SDKs. If you want to work in React, you want to work in Vue, you want to work in whatever. Um, so, and most importantly, working on the front end, you don't need to learn anything new. You
So
already know feature flags. And
how does
working
it
on
look
the
like?
back end,
So instead of
you don't need to
writing
learn.
like show this billing if this is an admin, then you simply get a boolean value of like can see the billing.
So you get a
Mm-hmm.
list of users or the feature flag, and that's what gets assigned into the feature flag solution. So OPA evaluates in real time the user list that's applicable for the feature flag using the same policy that you already have written there. So it's just an additional rule that queries your existing policy. And that information is what's loaded into your feature flag solution.
I've never actually used the feature flag solution before. Like usually I would just implement it like with a database or something. Yeah.
Yeah. So it's also something that's matured in the past, I'd say 3 years. So Launch Darkly, it's a unicorn now. It's a
Yeah.
multi-billion-dollar company, and they only do feature flags. That's the only
Mm.
thing they do. And yeah, and I recommend that type of service. In general, I think there's when you're building a new product, there's so many things that you need to implement. I think it's a shame to implement things that are already out there and work well. It's better to focus on your
Yeah.
proprietary stuff. That's at
Yeah,
least
for
my
sure.
experience.
I agree. So we actually talked before about the ABAC and how to implement that like practically from going from RBAC to ABAC, right?
Yeah. So so I'd start with kind of continuing on what I talked before. I'd start with a understanding if ABAC is the right policy for you and trying
So
to
maybe
avoid
you
the
can use a
pitfalls I
service
mentioned
and save
before.
yourself a
Uh,
lot of time so you can work on actual business logic and things that matter.
yeah, so that's kind of a given now, I guess. And if you do decide to implement it on your own, you really need to identify your key attributes. You need to track uh, in types of, in like almost tracing or at least architecture design where that data resides and how you make it available to your system. And you need to think on how you gradually move from RBAC. So I wouldn't start with, oh, let's do a quick cut shift to full ABAC at one day. Start with two attributes, combine them with your existing roles, do a test on that, do some benchmarking on your data loading, do some benchmarking on the pressure you're putting on your infrastructure through that. See that that works well, then consider additional
Hmm.
attributes.
I see.
So that's like a, a few tidbits of best practice I think that you can apply there. Um, and again, we talked also about an alternative
Right.
for ABAC, but still upgrading RBAC, and
ReBAC.
that's ReBAC, relationship based access control. With relationship based access control, what we do is we basically say which things go together or relate to one another. Um, for example, we can say this is the list of users that relates to a specific file or relates to a specific group. And we can say things like there's, for example, we've given the example of a partner before in a law firm. So that would be a separate list, and we'll have the um, user list, the overall user list, and the belonging to a specific tenant is a separate list. So we essentially get a bunch of lists that connect users, usually, or other entities, could also be services, to either groups or either identities. So the basic way to build ReBAC is with basically a kind of access control lists on steroids. So we have a lot of lists. The more modern way of doing ReBAC is using a graph. So, for example, this is really good for example, doing hierarchy-based stuff. Let's say something like Google Drive. I want to say that people that have access to the file are people that have direct access to the file, or people that have access to the folder that contains the file, or that have access to the folder that contains the file. You can imagine those as lists, or you can even better imagine those as graphs. So we have a node for the file, which is connected to a node. When I say graph, I mean obviously edges and nodes, and not the like
Mhm.
access graph. To be clear, so a computer science graph. So we have that file connected to a folder, connected to a folder, connected to a folder, and then that folder is connected to a user. Or it can also be connected to a role, which is connected to a
Mhm.
user. So that's would be the more
Yeah.
modern way of planning ReBAC, and then you resolve the graph by navigating on it. And this is would be a good place to mention uh, a project called Zanzibar, Google Zanzibar. So access control for Google Drive, for YouTube, for GitHub are all based on this white paper that Google published that defines how you build this graph and make it scale for like millions of users. And you can also, and there's open source that you can use to implement Zanzibar on your own. So Google didn't release any code because they're bastards. I'm joking. But you have companies like Ori that created Ori Keto. It used to be based on Opal, but they kind of re-implemented it. And I think the most matured, like the one that I've liked the most in terms of code quality, is a project called SpiceDB from a company called AuthZ.
So graph database, but
So
specialized for authorization and reback. By the way, what does
yeah,
like
exactly.
reback gives you
And
that RBAC doesn't? Because like every like relationship. So if we have roles, then I could just have a lot of different roles, just like I can have a lot of different groups. It's like it feels to me like it's the same thing, just in a different direction, isn't it? So what really does it give you?
so first of all, notice we got ownership kind of out of the box, which is harder to do with RBAC. You can do RBAC with ownership, um, but ReBAC has kind of it's easier to define ownership just as a relationship between
Mm-hmm.
two nodes, between a user and a resource or asset of some kind. And you can also do some attributes to some degree. For example, the attribute of residing in the United States. That's not a role, right?
Also, user can be assigned to multiple
But it's
groups
something.
essentially.
Yes, you can have multiple um, connections to for one node. That said, it just like with ABAC, it's really important not to overdo it. You have to. I can't clarify this enough. You have to keep your graph direct and acyclical. If you don't, just graph theory, right? If you don't, you'll end up having queries that are either don't end. They're You're constantly circulating on a graph without being able to resolve it, or will just take them a really long time to run. So it's also very important when you're building graph schemas, creating those relations, that you don't go too insane, and that you use an infrastructure. You use a graph database or use Zanzibar, something that is meant to
Hmm.
scale with
And or
that.
if you can define groups and then multiple groups and kind of give you like the same abilities that attributes give you, then what are like the considerations between reback and aback?
So with ABAC, you can get into more complexity than you can with ReBAC, and usually it will be more performant. In general, writing code with conditions will be more performant than
Hmm.
navigating on a graph. Obviously, it depends on the size of the graph, it depends on the complexity of the graph and its overall structure. But if you get into a complex situation where you have multiple conditions, if you start to do multiple navigations on the graph and cross lining them, that will take a lot longer than just evaluating a query of conditions
Got it.
on attributes.
Got it. Or I know we've been a bit over our time, so I'll take that as a. I
Mm,
can keep going and talking to you for hours. Probably, I'm fascinated by this conversation. So really, it was amazing. And maybe you can tell our viewers where they
thank
can
you.
find you and follow you if they want to learn more.
Yeah, yeah. First of all, I want to encourage people to do so. I'm super open and happy to connect with new people. And you can find me on GitHub, Twitter, LinkedIn. It's all Or Weis, ORWEIS. Uh, it's easy to find, and you're welcome to follow me and message me. I'm always happy to talk with fellow engineers and other good people. And Also, it's easy to find me on our own Slack channel and Permit's Slack community. You'll find it. There's a direct link on top in Permit.io. Just join there, and you can ask me any questions you want, especially if they're about authorization.
Awesome, awesome. So, thank you so much for attending. I had a lot of fun, and I'm sure people are gonna get tons of value out of this.
Thank you, Air. It was a pleasure for me to be on your show. Looking forward to
Yes,
talking
likewise.
more.
Bye bye.
Bye bye.